Finally, we'll take a quick peek at Descartes' Rule of Signs. Remember, we can check to see how many positive real roots and how many negative real roots we expect to find in a problem by looking at the sign changes between consecutive coefficients. So if I look at the coefficients of p of x, I see -1, +1, -2, +1, and +1. So there's a sign change here. I go from positive to negative here, from negative back to positive there, but no sign change between the last two numbers. So that's 3 sign changes. That means we either have 3 real positive roots or 1 real positive root, because the roots will come in pairs. Then if I want to find out how many negative real roots I have, I need to find p of -x. So first of all, if I look at p of -x, well, when I put a negative number into something to the 4th power, the sign won't change. So the coefficient will still be a -1. But when I put a negative into something with an odd power, the sign will change. So now I'm going to have another -1. Again, I'm going into something even. My sign won't be any different than it was originally. But when I go into something with an odd power, I'm going to have -1 as my coefficient. And then finally, +1 is not affected by substituting a -1 for x. So I notice I start out with 4 negative signs. And so there's only 1 sign change. So I have at most 1 real negative root. There really aren't any other options here. So given that I have 4 solutions altogether, I either have 3 positive real roots and 1 negative real root, or I have 1 real positive root, 1 real negative root, and I must have 2 imaginary roots as well. So this enables me to have a sense of what types of roots I can expect to have in this problem. It doesn't tell me what any of them are. It just tells me what I can expect about the types of roots and their signs.